Question number 16. A student on a camping expedition cools a sealed bottle of water which is at the same temperature as the surrounding air. Okay, it's a camping expedition. Remember, which method cools the water at the greatest rate, the highest rate? Okay, wrap the bottle in aluminum foil. So aluminum foil and in a shady place. Okay, fine. Shady place is okay. It will keep it cool. But then again, aluminum foil is not going to increase the rate of cooling. Okay, it's going to decrease the rate of cooling. So this is out. Wrap the bottle in dry white paper and put it in a sunny place. Okay, sunny place is definitely not the answer. Okay, wrap the bottle in foam and put it in a breeze. Okay, foam once again is an insulator, so it will also not let the rate of cooling faster, so it will decrease the rate of cooling. And wrap the bottle in wet paper and put it in a breeze. Okay, breeze is fine, it's windy, so it will definitely cool it at the greatest rate. And wet paper will also help. So overall, D is our correct option. All right, the student suggests three factors that affect the rate of emission of thermal energy by radiation from a hot object. The surface temperature of the object, okay, this is relevant. The surface area of the object, okay. Okay, this is also relevant. The surface color of the object. All right, all of these are relevant. Now, which suggestion are correct? All of them are correct. So 1, 2 and 3. Okay. Question number 18. A plane mirror on a vertical wall forms an image of an object placed in front of it. So it's a mirror, it forms a vertical wall, forms an image of an object placed in front of it. So which characteristics describe the image? Now, this image that we have is definitely going to be an upright one. Okay, and it's not real, so it's virtual and upright. Any kind of image that is formed on the mirror is always virtual. So we have these two options, but inverted, we don't see ourselves inverted in the mirror, so upright is your correct option. The diagram shows lighting travels in air incident on the surface of a glass block. Some light is reflected and some light is refracted. Which diagram shows the reflection and the refraction of the light? Okay, so as we can see that over here, the first thing is air to glass. Air to glass means lighter to denser medium. So in this case, our incident ray is going to bend towards the normal. Okay, so if it bends towards the normal, then we have got this option is okay. This is incorrect. This is moving away, so it's also incorrect. This is also a possible answer. Now let's look at A once again. In A, we can see that it's reflecting somewhere here, which is not possible. If it has to reflect, then it should reflect over here, and as a result, D is our correct answer. Okay, which statement is correct? Four statements are given. Total internal reflection occurs when light travels from air into glass. Okay, when light travels from air into glass. Like we cannot say that for sure. Okay, for total internal reflection to occur, we need to have critical angle. That is our only requirement. Okay, the requirement is not from lighter to denser medium, so this is not the correct option. The larger the refractive index of the glass, the larger is the critical angle. Okay, not necessarily. Refractive index has something to do with the critical angle, as we know that n equals to 1 by sine c. But then again, like we can never say that if it's larger, then the larger will be the critical angle. So we have to rule this out. When total internal reflection occurs, the angle of incidence is equal to the angle of reflection. Okay, that's a possibility. Let's keep it for now. When total internal reflection occurs, the angle of incidence is less than the critical angle. That's not possible, because for total internal reflection to occur, the critical angle needs to be more then the angle of incidence need to be more than the critical angle. So in this case, the opposite thing has been mentioned. So the correct option that we have is C. Okay, let's move on to the other question number 21. Object is placed in front of a converging lens of focal length 4 centimeter. So over here we can see the focal length is 4 centimeter. Okay, so one of these boxes represent 2 and the other box represents 2, so altogether we have 4. So one of these boxes represents 2 by 2. Okay, so the height of the image is 6 centimeters. So with a height of 6 centimeter, we have 2, 2 and 2, altogether 6 centimeter the object the image height, and the object height will be 2 and a half, that means 3 centimeter altogether. So now linear magnification would be image height divided by object height. Okay, so in this case our correct option is 2C. Okay, which range of sound frequencies includes only frequencies of sound that can be heard by human ear? Okay, so they're looking for audible ranges. So audible ranges 0.5, this is not possible. The lowest range is should be at least 20. Okay, 5 is not also possible. The highest range, okay, can be 20,000 hertz. So this is not possible. The only option that we have is C. Okay, aircraft flying through the air becomes electrically charged. So why is that? What causes this to happen? Now, background radiation in the aircraft. Okay, this is something related to radioactivity, which is not possible. Friction of the aircraft with the air. Okay, it could be a possibility. Let's look at the other options. Heating of the aircraft surface. If the aircraft surface becomes heated, then how can it become it will not aid to electrical charging. Okay, radio waves emitted by the aircraft. Radio waves can be emitted by the aircraft, but it has nothing to do with electrical charge. So the correct option that we have is B. Okay, two metal spheres are brought close to each other. Two metal spheres repel each other. Both spheres are charged and both are positive. Now we cannot say for sure that both of them are positive, but this could be a possibility. Let's say because they are similar. Both spheres are charged, but one is positive, and that this is not possible because they have opposite kind of charges which will attract instead of repulsion. The spheres have the same number of electrons. Okay, number of electrons does not mean anything. The spheres have the same number of protons does not mean anything. The correct option that we have is A. As student sets up the circuit shown, the lamp does not light. Okay, the lamp, we can see we have a diode over here. So the diodes have got orientations. Okay, we have got forward bias diode or reverse bias diode. So this one, I mean, is placed incorrectly within the circuit. So if we correct the diode connection, that would fix it. Okay, that would fix it. So in this case, let's see the options. Changing the supply to a 12-volt battery, no. The battery voltage increment would not lead to correction. Inserting a fuse, no. Okay, reversing the battery connections, yes, it might change, because when we reverse the battery connections, okay, like this, then we have got the diode to be forward biased in the same orientation. Okay, now the positive of the diode is connected to the positive side and the negative of the diode is connected to the negative side. So as a result, yes, it could be an option. Reversing the connections to the lamp. Okay, nothing will happen if we change the orientation of the lamp. So C is your correct answer. Circuit P and Q have each contain two identical resistors, each of resistance R. Okay, the R are identical. All these are identical. What is the resistance of circuit P and of circuit Q? All right, over here, if we have two identical resistance, then we will have a combined resistance of 2R. And over here, if we have two similar R, then we will have a combined resistance of R combined will be half R. Okay, So R by 2 and 2R, C, as I can see, C is our correct option. The current in an electric motor is 2 ampere. It transfers 20 joules of energy in 5 seconds. What is the potential difference across the motor? So we can see E will be equals to VIT. Over here, V will be equals to E divided by IT, and E is 20 joules by 2 ampere multiplied 5 seconds. So that will be equivalent to 2 volts. B is our correct option. Three students make comments about appliances with double insulations. Okay. Student P, appliances with double insulation do not need an hardware. Well, okay. Do not need an hardware. Fine. This is true. This is true because the double insulation protects the user from an electrocution or shock. So that is true. Double insulation protects the user of the appliance from an electric shock. Okay. I mean, not necessarily, but it is a safety feature. Yes. Okay. The circuits of appliances with double insulation do not contain fuses. um, okay, which students are correct? So over here, as we can see, that double insulation can protect the user, but it does not contain a fuse is not appropriate. Okay, it might contain fuse, and it will be another added safety feature. So the option is P and Q. The correct option is P and Q. A magnet moves at constant speed through a coil of wire. The coil is connected to an oscilloscope, and as we can see that the oscilloscope trace is this one. Okay, now they have a new trace which looks like different from that of the first one, and we can see there is a delay. Okay, so which statement explains why the new trace is different from the original trace? Let's see. The coil is longer, and the other pole of the magnet enters the coil first. Okay, this could be an answer, as we have got a delay, so the coil might be longer. Or the coil is longer and the same pole of the magnet enters the first coil. Same pole, if it was for same pole, then we would have this at first. Okay, we would have it like this. We would have it okay, we would have it like this, and then this one. Okay, so in this case that is not happening, so we can say that this is not possible, and shorter coil is definitely not possible, both of them, because we have got a delay. Okay, the delay suggests that there is a longer coil, so the only option is A. All right, a bar magnet is dropped through a vertical solenoid that is connected to a sensitive ammeter. All right, current is induced in the solenoid, and the solenoid becomes an electromagnet, as we can see. Which row describes the polarity of end Y? Polarity of end Y of the solenoid. Okay, and the force between the solenoid and the bar. And okay, so once it's inside, let's see, this will still be a south, this will still be a north. So over here north, over here south, so we'll have north. So the options, polarity of end Y of the solenoid, we will have both of these options, A and B. At force between solenoid and bar magnet. Okay, force between solenoid and bar magnet will be attraction. Okay, will not be a repulsion, because if it has to repel, it will have a repulsion at the beginning. It will create a similar kind of pole over here just to repel, so that we mechanically need to push the bar magnet. Okay, and other than that we will have attraction. So altogether we will have A as our option, and the rest of it is